Hi Math, I'm Andy. Today, let's take a look at indefinite integrals, and we're going to have to use the process of change of variables, or in a sense, the substitution process for integration, in order to integrate this function, x times the square root of 2x minus 1 dx. Now we can't just integrate straight off, so we need to kind of rethink this. Here's really what our goal is. Because this is like a composite function, our goal is to find this pattern where we have a composite of f of g of x times g prime of x dx. That's really what we want, because this integrates really nicely. This is actually just going to integrate into the f of g of x plus c. And so that's kind of what we want. Now we're going to pull a substitution. So here's really what we're going to be looking for. The f of u du. And this will integrate as the integral of f of u plus c. So that's kind of like our goal. So let's kind of pull some maneuvers. I notice that there's this 2x minus 1 that is ultimately a function within a function. So I'm going to think of that as my g of x, and in this case for my substitution, I'm going to name that u. So u is 2x minus 1. Now let's take the derivative of u and let's figure out what du is. Du is 2 dx. Now inside my function, I notice that I have my u here, but I'm missing that 2. And at the same time, I have this x that's still here that's unaccounted for. So the dx is accounted for, the 2x minus 1 is accounted for. The square root will be accounted for because it's u to the 1/2, but this x is still not a part of my u du because that's what I'm looking for. So I kind of have to be manipulative and sneaky here. I'm going to do two things. First, I'm going to take this idea that u is equal to 2x minus 1, and I'm going to solve for x. So I'm going to add 1 to both sides. I get u plus 1 equals 2x, and divide by 2, and so u plus 1 over 2 is x. So now this x here, I'm going to be able to substitute a u value for that x. Now I'm also going to have to account for this 2 that I have in my du. So I'm going to kind of pull a little substitution trick there as well. And I'm going to take this idea that du is equal to 2 dx, and I'm just going to divide by 2 on both sides. So now dx is equal to du over 2. So by doing this, I'm going to be able to rewrite this integral using just my u's and du's by substitution. So let's take a look at what this integral ends up looking like. So my original problem was x times the square root of 2x minus 1 dx, and now I'm going to do all my substitutions. So I have an integral, but instead of the x, I'm going to call it a u plus 1 over 2. Instead of the square root of 2x minus 1, I have a square root of u, and I'm going to rewrite it as u to the 1/2, because remember, 2x minus 1 is what u is, and so the square root of 2x minus 1 is really the square root of u. I'm just going to write it like this because I'm going to use my power rule. And then dx isn't dx anymore, it's du over 2. So I took my problem and I've rewritten it in this u. Now let me simplify this. I have a constant multiplier of these 1 over 2's, so I'm going to pull those out into the front of my problem. So that constant multiplier of 1/4 is just going to be in the front. We'll deal with that later. Now I have this u plus 1 being multiplied by u to the 1/2, so it's almost like I'm going to distribute. So this is going to give me a u to the 3/2 plus a u to the 1/2, and then my du is still a part of my problem. And now that I've rewritten this with u's, I can just integrate using my power rule. Now the power rule says that we add 1 to our exponent and we divide by the exponent. So let's integrate. That 1/4 is still hanging out, and u to the 3/2 becomes u to the 5/2 over 5/2. The u to the 1/2 becomes u to the 3/2 over 3/2. And then because this is an indefinite integral, we're going to add c. Now the last piece of our puzzle is we're going to want to go back and confirm the u's. We're going to substitute what u really is, and then we might just want to simplify some of this. And so I'm going to distribute the 1/4 to both of these things, and a fraction in my denominator isn't really what I want, so I'm going to simplify that. 5 over 2 in my denominator is the same as 2 over 5, right? Because I would multiply by the reciprocal on top and bottom. And then the 2 and the 4 in this case are going to cancel out, and this is going to become a 2. And so this is going to be a 10 in my denominator, and I've applied this 1/4 to it. So this thing will happen here as well. The 3 over 2 in my denominator is actually going to become a 2/3. The 2 and the 4 are going to cancel, and then the 2 times the 3 is going to become a 6. So this kind of just simplifies that matter. And now let's go back and write our final answer with our u substitution. U is really 2x minus 1. So I have this 1/10 times 2x minus 1 to the 5/2 plus 1/6 2x minus 1 to the 3/2, and then plus c for my indefinite integral. And so that was indefinite integrals, a change of variables using our u substitution. Remember, we retook our problem and we rewrote it as things with u to make our integral easier, and then we went back and substituted what u stood for.